Hello everyone, welcome to Indian School of Physics, guys. This is Nitin here, and today I have come up with one of the champs assignment, and it is a basically JEE Mains 2025 revision material, and yeah, you can say like it is specifically designed for JEE Mains, and in the champs program you can find all topic-wise such units. So let's quickly revise this work power and energy topic from mains point of view. All right. So yeah, as you can see here, there is introduction. So I think I'll keep the speed slow so that if you want, you can take the screenshot of it and you can use this for your own purpose. Right. So here you can see the introduction part about the work, and one example is given that work will be considered only if there is displacement in the body, or more precisely if I say it is point of application of force. So here, as you can see, work done by a constant force. So this work done is F dot S. Please remember here this is for a constant force, and this S is displacement of point of application of force. All right. So there are two ways by which we can resolve. So if you are part of regular classes, you'll know that. So this F dot S we can derive in two manners. We can take component of displacement in the direction of force, or we can take component of force in the direction of displacement. Both ways it will be giving you the same application. So one situation I have taken here, and you can see here if it is F, and we can take perpendicular component, and this will be S cos theta, so Fs cos theta. Or another way is we can take component of this force along the displacement, so this will become F cos theta, and total displacement if you multiply with that. Okay, the next part is work is scalar quantity. I think it's easy, you can just go through this, probably you'll remember also, and you'll be using these formulas both in both maths and physics and chemistry. All right. Nature of work done, you can say if angle is 90-degree displacement and W is 0. If it is acute angle, then positive. If it is obtuse angle, it is negative. So it is from the very basic level, and it will cover the entire topic for you. Work done by multiple forces. So if there are many forces here, so we can write total work done by as if we are calculating the work done of individual forces. Since total displacement is going to be constant, we can simply write F net dot ds also. So one very basic level example is given. If we lift a body from rest to a height of h, so Wmg is minus mgh, and W agent is Fh. So yes, you can see the net work done on the body also. The next part is if body is in equilibrium, then F equal to mg, and in that case W external and W mg will become equal, and net work done will become 0 in that situation. Okay, so if a body is pulled on a rough horizontal surface through a displacement of S, in that case work done by first see the FBD. So there is a normal reaction from the ground, mg, friction, and this F, and displacement is here. So we can say W normal, Wmg equal to 0 directly, because angle is 90-degree, and friction minus Fs, and due to this agent plus F capital S. All right, and if it is since it is moving, friction value will be mu into n. It will be kinetic friction, so minus mu mgs overall work done. Then there are some important conceptual points here. Work done is 0 if force and displacement are perpendicular, displacement of point of application of force is 0, and the net work done on the body is 0. So it may be possible if net force is 0, then individual forces may do work, but overall net work done we can say will always be 0. That is the extension of work energy theorem, by the way. So so here some more examples are given, as you can see. Some important point about work. Work is defined for an interval. So since displacement happens in an interval, so work is defined for interval, and there is no it is absurd to say instantaneous work done. Like we have instantaneous acceleration, we have instantaneous velocity, so all those are meaningful. But if we talk about you can say instantaneous work, it is meaningless. All right. So now some points are written here. I'll just read it. For particular displacement, work done by a force is independent of type of motion, that is whether it moves with the constant velocity, constant acceleration, or retardation. For a particular displacement, work is independent of time. Work will be same for same displacement whether time taken is small or large. So it doesn't matter how much time it is taking from one point to another point. The main idea is what is the displacement in that time. So it depends on the displacement and its orientation. Next is area under force displacement curve. That will give you the work, and if force is changing its direction, so you can say like it will follow the same rule as area. So if curve is above the x-axis here or y, whatever displacement basically, so positive work done, and otherwise negative work done. Now there is a very small this examples I have taken here. JEE means Feb 2023. So question is, a small particle moves to a position, its position is given from its initial. So r final, r initial is given under the action of force. This force is given, value they are asking. So r2 minus r1 will become displacement, and then we need to take dot product, and directly we can get it. Such a easy question, and it came in means 2023. Then another question we can take: a particle moves in one dimension from rest under the influence of a force that varies with the distance traveled, as shown in the figure, and the work done by the particle after it has traveled 3 meter distance. So simply we need to write area inside this curve, right? So we can break this into two parts. One is this rectangle, and one is this trapezium. So when you do that, this is very simple. 2 into 2, that is 4 units, and here half sum of parallel sides, so half 2 plus 3 into distance between them, that is 1. So when you simplify, you are going to get this as the answer. I hope it is clear to you. And the next question is, a block of mass m, this came in means 2029. So a block of mass m kept on a platform which starts from rest with a constant acceleration of g by 2 upwards. The work done by the normal reaction. So first thing is, in normal reaction value we need to find, and then we need to multiply it with the displacement. So that is also happening in this direction. So positive work done. So first thing is, if you draw the FBD, normal upward, mg downward, so n minus mg equal to ma, or by pseudo force also you can do that. But again, to calculate the work done, you need to come to the ground frame. So n value is m times g plus a. So 3 mg by 2 is the normal reaction, and displacement is half at square. So just take this dot product, and you will get this work done as 3m g square t square by 8. It's such a simple question. And after this, let's take another problem. A block of mass m is taken from A to B under the action of constant force. Work done by this force is, so from here to here we have to calculate work done. So displacement in the direction of force, so F into displacement in this direction of force, directly we can write. Next part is, a pendulum of mass m length L is suspended from ceiling of a trolley. Constant acceleration is given to it. The work done by tension they are asking. In the frame of trolley, please remember, from the ground frame the path is complex, but if you are present in the trolley frame itself, then you will find it is moving in a circular motion, and tension will be always perpendicular to that path, and directly we can write in that case, since with respect to trolley, path of particle is circle, work done by tension is 0. Let's come to the next problem. There is a very similar problem, that a small block of mass m is kept on a rough inclined plane of inclination theta, and it is placed on a elevator and it is moving up with the uniform velocity, all right, and block is not moving. So if block is not moving, so there must be some force in order to balance it, and that is force of friction, and its value is equal to mg sine theta, which is down the incline. Normal reaction is n, and this is mg cos theta. So Fr must be equal to mg sine theta, and displacement is happening in this direction, and that is Vt. So we have to take this component because friction is in this direction. So mg sine theta into this distance Vt, and this angle is 9 theta. So 90 minus theta, sine theta will come. So mg sine theta into Vt sine theta. This is the answer for this one. So mains questions are going to be very, very easy in my opinion, and you have to have just accuracy as well as some speed you may require in order to get full out of full. But I'm pretty sure this booklet will definitely help you in getting full marks, especially in mains. So here the next problem is a small block of mass 20 kg rests on a bigger block of mass 30 kg which lies on a smooth horizontal plane. Initially the whole system is at rest. The coefficient of friction between the block is 0.5. A horizontal force F is equal to 50 Newton is applied on the lower block. Find the work done by the frictional force on the upper block at T equal to. So this question is also easy. Here they are asking work done by friction force on the upper block. So first we need to check whether friction is static or kinetic here. So what you can do is, let's assume it is static, so it will be moving with the same acceleration, and let's find out that acceleration. After that you can check on the upper block, and you can find out that force of friction is coming as 20 Newton. Upper block is moving only because of friction. So F equal to ma we are applying, A we know already. Okay. Now F max is 0.5 into 20 G. So that value comes as 100 Newton. So yes, this will be within the limit. That means whatever assumption we have taken is acceptable. Okay, so friction value is known to us. Displacement also is known to us because half AT square we can apply, and A value is this. So now work done by friction on upper block is plus of friction value multiplied by the displacement, that is 2, plus 40 joules is coming. So since it is static friction, work done by friction on the lower block will be minus 40 joules, because work done by static friction as a whole is going to be 0. Alright, so similarly here you can see, you can take screenshot of this. Like this I have covered all the parts. Here work done by variable force, if you see, so there is a, see, the basic definition is F dot ds. Now its applications are there. So if you find out in your notes different variation, at least some 8-9 variation I have covered in the regular classes. So it's a simple here, if vector F is given like this, dx you can write dr or ds or dl, anything you can write, dx I cap plus dy j cap plus dz k cap. So w will become F dot ds. Integrate this x1 to x2, y1 to y2, z1 to z2. This is how we are going to calculate this. Now one question is given, and purposely it is taken on you can say exact differential. Okay, na? So what is given here? There is a variable force F, and dl length is given. So these are standard terms. A particle of mass 2 kg is being acted upon by a variable force. So force expression is given. Whenever such symmetrical functions are given, just think from the idea of you can say exact differential, otherwise path has to be given. Luckily here it is given the particles taken from 0, 0 to AA along different paths. Based on the above fact, the work done is to take the particle from 0, 0 to A, 0 is. Here they are not mentioning the path, so that should be a clear hint that definitely in this case exact differential is going to work. So work done is F dot dl. When you see this, Now this should give you enough in first function into differential of second plus second function into differential of first one. When you do that, you will see that it is d of x cube y cube by 3. All right, now integral dw is very easy to calculate. Point is given, so product of this x square y cube you have to write, and this work done comes out to be 0 here, and it is given 2 to the power delta minus 4 is 0, and so delta is equal to 2. That is the answer. 10 delta they are asking, so 20 is going to be the answer. So be careful like what exactly they are asking. It's a good problem. All right, let's move to the next one. This I'm leaving it to you. However, it's on the easier side. I'll be covering in the regular lecture, however. So you can see path is AB, BC, CD, and this DE and EF and FA. So it's a closed path is given here, and force is AY I cap plus 2AX J cap. So what we have to do is we have to see this line. In this line, Y is 1 and dy is 0. So along X we can easily do that part. We can break this into a lot of such questions I have done in the class. However, you can see it's on the easier side only. Like you take AB path. So AB path properties are y is 1, dy is 0, and only it varies with the x. So AY into dx, because dy is 0, so AY into dx is coming, and y value is 1 here, so a dx, and limit goes from 0 to 1. So like this we can calculate. For BC, x is constant, so dx is 0, y is changing. In BC, dx is 0. Dx is 0 means due to this part force will, work will become 0, and 2ax, x is fixed for this, so force is 2a j cap. We can calculate the work done. We are moving down, so negative work done. Similarly for CD, DE and EF and this. I hope this part is clear to you. So give it a try and share what is your answer for this particular problem. Then next is JEE 2020 question. This is also like extremely easy problem. However, this will be a very tricky one. If it was x and y were reversed, it will become a very good problem in that case. It's still solvable. So directly x term minus x dx plus y dy, and we are going from 1, 0 to 0, 1. You can substitute the limit and you can get the answer for this. All right. Similarly, another J-means problem. This is when a rubber band is stretched by distance x, it is exerting a restoring force of magnitude F equal to ax plus bx square, where a and b are constant. The work done in stretching the unstretched rubber band by L. Okay, so f dx only we have to do. So ax dx plus bx square dx, and if we integrate this from 0 to L, we'll get L square by 2 plus BL cube by 3. I think this should be the answer. Like we calculate work done for work done in case of spring force. Something similar to that is given. All right, here energy definition is given. Energy is defined as internal capacity of doing work. Basically, energy and work is similar type of quantity, same unit. They can convert and also heat as well. So they can convert into one another. Kinetic energy definitions of all these things I don't need to tell you, but I think you are everyone should know this. You can't. This relation is also pretty handy, especially we have done recently modern physics, and you know, very frequently we are going to deal equations in this form. Some important points are there. Just give a reading to this part, and I think you will be all set to go. Then yeah, some graphs are there, as you know, like JEE will be asking these graphs frequently. Kinetic energy versus momentum. So K is P square by 2m, so y equal to x squared kind of graph. root K versus kinetic energy, root K versus P. So P is equal to under root of 2 mk, y equal to mx wala line. Then if it is straight line, and then 1 by P, if we do, it will become rectangular hyperbola. So these graphs are easy. I think no one will make a mistake in that. Now similarly here, if you see a particle, this is projectile motion. It's very nice. This is different perspective of projectile motion. A particle is projected up from a point at an angle of theta with the horizontal at any time t. If p is the linear momentum, y is the vertical displacement, x is the horizontal displacement, then the nature of curve drawn from k of the particle gains this parameter. So ky graph, y is the vertical height. So it's a very simple. We can say v square is equal to e square minus 2gy. V square, half m, if we multiply, we will get the kinetic energy relation. Similarly, KT graph. Now y value we can write in vertical direction as u sine theta t minus half gt square. So yes, if this is a straight line, here we are getting. Now y is t square term is coming, so KT graph will become a parabola like this. And by the way, you can see here it's a minus y is coming. So if projectile is going like this, so kinetic energy with time will change in this manner. Easily also you can see, as it is going up, its speed is decreasing. It will be minimum at topmost point. After that, speed will further increase. Kx graph, same way. Y की जगह क्या करेंगे? We will write y is equal to x tan theta minus gx square by 2 v naught square cos square theta. So equation of trajectory we can use here. All right, equation of trajectory we can use here. So that is also a parabola. So you can see, as projectile is going up, kinetic energy as a function of x is decreasing and then increasing again. Similarly, Kp graph, straight line. Now these type of questions are very common in case of WP. The kinetic energy of body is increased by 21%. What is the percentage increase in the magnitude of linear momentum of the body? So we will use that formula. There are many methods. One such method is given here. However, I am going to tell you another method. So P square is equal to 2mk. All right. Now kinetic energy is directly increased. So from here you will get 2 dp by p is equal to dk by k. So you can see double of this will come. And here, what is the percentage increase in the linear momentum? That is increased by 21%. So you can check what is the percentage increase. You do the calculation. I think it's easier side only. It should work. All right. P square is equal to 2mk. We can write kinetic energy. If we are increasing, momentum also will increase. ठीक है, log लेके differentiate कर दो भाई इसको. ठीक है भाई. Yeah, I think. The next is it came in JEE Mains Feb 2021. Two solids A and B of mass 1 and 2 kg are moving with equal linear momentum. Their ratio of kinetic energy, same formula we can use, P square by 2m. So I'm not going to solve these questions. Quickly, just for revision purpose also, you have to just see it once whether you are able to solve these or not. Now kinetic energy is same ratio of their momentum. So P is equal to under root of 2mk. K is same, so root m2 by m1 will come. All right. So you can check P2. Root 4, yeah, 2 or 1 by 2, whatever, that you can check. Work done by internal forces. Work done by internal forces, just see here, internal external is completely your choice. That all the time ठीक है ना. See, the resultant of because these two forces will be always in terms of action reaction pair, so their net force will be zero, but the work done by these internal forces may or may not be zero. Spring is one such example. All right. Kinetic energy, work, all these are frame dependent quantity. So when we are applying work energy theorem from a non-inertial frame, in that case we need to consider work done by pseudo force as well. Like how we calculate further, exact similar idea will follow. So there is potential energy. So W conservative is equal to minus delta U. This you have to remember, or simply W conservative is equal to U initial minus U final can be written here. I hope this part is clear to you. So similarly, gravitational potential energy, spring potential energy. All right. Conservative, non-conservative forces, we can see the definition of these forces. Force is conservative if work done by force is zero in a closed path. And another property is work done by the conservative force will be independent of path. That means it depends only on the initial and final stages. Doesn't matter which path you choose for the conservative. And there is no loss of energy takes place in presence of conservative forces. All right. Then here we have non-conservative forces. Exact reverse definition we can apply. Friction, viscous force, drag forces are the example of non-conservative forces. Similarly, spring force, I think now this is easier. Okay. W spring is minus kx dx will come. Then whatever desired limits are given you can use, or you can write U initial minus U final also. So if we take reference at say natural length, then x1 to x2 extension is U initial minus U final. So directly I can write half k x1 square minus x2 square. Work energy theorem I think is easy and you will be aware of it. W net equal to change in kinetic energy. When we are writing, we are considering all forces. Mechanical energy of system. Now mechanical energy of system will be conserved only if work done by all the forces other than conservative is zero. Then these are some more basic questions I think easily you can do. This is, by the way, classroom example. We cover this in classroom. You can see. You try to solve it on your own based on the discussion so far. And here its solution is also given so that you can check your answer afterwards. Then another one is a particle is thrown with a velocity v0 on a rough inclined plane. The distance traveled by the particle during the upward motion is d. So v square is equal to 2as we can write, and upward acceleration or you can say deceleration, it will be either work energy theorem you can apply, or simply mg sine theta is this side and friction is also, so g sine theta plus mu g cos theta, like that it will come. Or in terms of work energy theorem you can write simply v square is equal to 2as. We are applying here a down the incline, g sine theta plus mu g cos theta. There is another easy problem. Okay, so I'm leaving all these problems for you to work on. Just take this screenshot, then take this screenshot. Some of these booklets I may release if you want. I will release some of these books. All may not be possible because these are part of the champs batch, but yeah, few we can release. Like earlier also, some of the main specific topic books, INSP books I have released, so you can use it for your preparation. Okay. Take the screenshot of this. This is also a PYQ, very important one. Then this question, you can take the screenshot of it. Okay, this is the extension of it. And then quickly you can take for this part as well. This looks similar. Okay, different problem. Let's see that. Maximum downward displacement of block. For these problems, I have discussed some shortcuts. So you can use that also in the regular classes. This is also another very easy problem. So mu naught mg by 2. It is the extension of Irodov problem, where f is equal to mu1 mbg, mu b mgb, and here mu naught mag by 2. So just see that. Similarly, this question you can take here based on energy conservation. Another means PYQ. So you can give it a try. Take the screenshot. Then the next one. And then here this problem. All right. Very easy. Very easy. But means will have these kind of questions only. Then equilibrium wise, stable, unstable, neutral. In the classes, it has been covered at very much depth. Here again, we'll quickly revise from the mains point of view. You can see here all information is provided. For a stable, then unstable, and then neutral equilibrium, and potential energy and its equilibrium here. Okay, we cover it through radius of curvature also, and this problem is good. However, what they asked was very simple: x component of force. So if potential function is known to you, minus del u by del x I cap minus del u by del y j cap minus del u by del z k cap. This is going to be the force at any point x comma y comma z. Now you can put x equal to 1, y equal to 2, and z equal to 3. All right. Then this is based on again potential function, equilibrium, distance between the two atoms. So R equilibrium they are asking basically. So for equilibrium, what you will do is, from potential energy you will get the force, and for equilibrium what you will do is force equal to 0. You will simplify and you will get one answer. Similarly, by seeing this force here, F equal to minus du by dx, this is unstable equilibrium, by the way. X1 is unstable equilibrium, X2 is unstable. These are not equilibrium except this. Okay, so none of these you can say. Similarly, this is another question, separation between the potential energy. So same question, force equal to 0, R you will get that R value in potential function, then you will get the potential energy part. Similarly, another UX graph, easy problem, just give it a try. Then this is given, this is also easy. At maximum or minimum compression, always remember the V relative along the length of the spring will be 0. That is the concept used here. And similarly, some more things about power. So I think this is the easy part, application of power. You can see, just if you want, you can take a screenshot of this. Then this part. After this, there are some points related to power. Then working of motor pump also, like work done against the gravity plus change in kinetic energy. Position and velocity of a automobile with respect to time. So normally they will give the power. So here it is given as a constant power. Okay, so F dot V is constant. After that it becomes a kinematics problem. Velocity time graph easy, you can substitute the values. Similarly for position. Next, it is given automobile of mass m accelerate from origin and initially at rest while the engine supplies constant power. It is the previous problem only. See, the answer is also very similar. Not very similar, in fact the same answer, but the way we are asking is slightly different. Similarly, question number 40, you can just see that. Okay? If you want, you can take the screenshot of this. About the lift, it came in mains. Quickly you can go through all these problems. I think this is the last problem, 46. Yeah, easy, very standard circular motion problem. Yeah, that's it. Let me know if you like this kind of mains material to be used. These are official CHAMPS programs modules, mainly for revision purpose, so that you don't have to search for a lot of books, and very easily you can